Last class we discussed about Laplace transform of periodic function. Today's class will discuss about Laplace transform of step function. So let me tell you what is step function. So we all know what is a function. Function is just a relation between two things. So here, so I am related to you as a faculty. You are related to me as students. So step function means from the name itself you can understand that it is you jump from one thing to the other. So step function in mathematics, it is defined as jumping from 0 to some quantity. So if you jump from 0 to some positive quantity, say k, it is called as the step function. If you jump from 0 to some positive quantity k, it is called as a step function. If the positive quantity is 1, it is called as the unit step function. Let's say that you are traveling at a speed of 30 kilometers for the first you are traveling at a speed of 30 kilometers per hour for the first 10 kilometers. After crossing 10 kilometers, you increase the speed. So you have the concept of step function. Let's say that you are traveling at a speed of 30 kilometers per hour for the first 10 kilometers, and after crossing 10 kilometers you are increasing the speed. So that is, there you have the concept of step function. So I repeat, step function, it means you are jumping from, the function jumps from 0 to positive quantity. If that positive quantity is 1, it is called as a unit step function. So it is denoted by u of t minus a, which is equal to 0 when t less than or equal to a, 1 when t greater than a. So u of t minus a is called as the unit step function. Step function was by Oliver Heaviside, so it is also called as Heaviside function. So you have two notations for step function: u of t minus a, h of t minus a. Now here we have the properties of step function. The first one, Laplace of step function is e power minus as by s. So what is the definition of Laplace transform? You take a real valued function f of t and multiply with the kernel e power minus s. Multiply with the kernel e power minus st, and you integrate the product with respect to t from 0 to infinity. If such an integral exists, then we call it as Laplace of f of t. If the integral exists, we call it as Laplace of f of t. So Laplace doesn't exist for all functions. It exists only for some functions. Next class I will discuss the conditions for the function to have the Laplace transform. Now, so here we have to find Laplace of the step function. So in place of f of t, you have u of t minus a. So integral 0 to infinity u of t minus a e power minus st dt. Now how step function is defined? 0 from when from 0 to a, and from a to infinity it is 1. So integral a to infinity 1 into e power minus st dt. So what is integral e power minus st? It is integral, what is integral e power minus st? E power minus st by minus s from a to infinity. So when you substitute the limits, it is minus 1 by s e power minus infinity minus e power minus as, and e power minus infinity is 0. So you will get e power minus as by s. So the first property is Laplace of step function is e power minus as by s. Next one, the second property is for finding the Laplace of the product with the step function. So I told you the product rule is not there in Laplace transform. So whenever you have the product, a function with step function, you have to make use of Heaviside shift theorem. So what is the statement? If L of f of t equals f of s, so it means that Laplace transform of f of t exists. When you say L of f of t equals f of s, it means that Laplace transform of f of t exists. Then Laplace of the product f of t minus a u of t minus a e power minus as f of s. So the Laplace of the product f of t minus a u of t minus a is defined as e power minus as f of s. So start with the definition. What is the definition of Laplace integral 0 to infinity e power minus st f of t dt? So in place of f of t, you have u of t minus a, f of t minus a. In place of f of t, you have the product u of t minus a, f of t minus a. Since you have the step function, you split the integral into two integrals. So how the step function is defined? 0 for t less than a, 1 for t greater than or equal to a. So the integral exists only from a to infinity, that is u of t minus a is 1. So 1 into e power minus st f of t minus a dt. In the next step, we take p as t minus a. So dp is dt, and if t is a, p is 0. If t is infinity, p is infinity. At t equals a, p is 0. At t equals infinity, p is infinity. So integral p equals 0 to infinity e power minus sp plus a f of p dp. So now you have the exponential term split into two exponential. So it is e power minus as into integral 0 to infinity e power minus sp f of p dp. So split the exponential term e power minus as is outside. Integral p equals 0 to infinity e power minus sp f of t dp. So this integral is nothing but Laplace of the function, that is f of s. So we have the Heaviside shift theorem. Laplace of f of t minus a u of t minus a as e power minus as f of s. Now in particular, if f of t minus a is 1, then this result becomes L of u of t minus a e power minus as f of s. What is f of s? L of f of t. When you say that f of t minus a is 1, f of t is also 1. So e power minus as into L of 1. So what is L of 1? Laplace of constant function 1 is 1 by s. So 1 by s e power minus as. So you should remember the statements of properties with proof. So first one, Laplace of the step function e power minus as by s. Second one, Laplace of the product, that is Heaviside shift theorem, e power minus as into f of s. You will be using in all the problems. Now next we have two theorems. If f of t is defined in two subintervals, like as f1 of t for t less than or equal to a, and f2 of t for t greater than a. If f of t is defined in two subintervals, f1 of t for t less than a and f2 of t for t greater than a, then f of t can be expressed as f1 of t plus f2 minus f1 into u of t minus a. So I repeat, when you have f of t expressed in two subintervals, f1, f2, then f of t can be written as f1 plus f2 minus f1 u of t minus a. You don't have to learn the proof for this theorem. Similarly, for the second one, second theorem, if f of t is defined in three subintervals, f1 of t for t less than or equal to a, f2 of t for t lying between a and b, f3 of t for t greater than b, then f of t can be written as f1 plus f2 minus f1 u of t minus a plus f3 minus f2 u of t minus b. So if you have f of t expressed in two subintervals, make use of theorem 1. If you have f of t expressed in three subintervals, make use of theorem 2. So you don't have to learn the proof for these two theorems, but you should remember the statements we will be using in problems. Now first problem, find the Laplace transform of e power t minus 2 plus sine of t minus 2 into u of t minus 2. So here you have to find the Laplace transform of the product. Whenever you have to find Laplace transform of the product, make use of Heaviside shift theorem. What is Heaviside shift theorem? Laplace of f of t minus a u of t minus a equals e power minus a s f of s. So what is split it into two terms, Laplace of e power t minus 2 u of t minus 2 plus Laplace of sine of t minus 2 u of t minus 2. So what is it? What is a here? 2. So e power minus 2s f of s, and here also e power minus 2s f of s. And what is f of t here? E power t. If f of t minus 2 is e power t minus 2, what is f of t? E power t. And what is f of t here? Sin t. If f of t minus 2 is sine of t minus 2, what is f of t? Sin t. So e power minus 2s into L of e power t plus e power minus 2s into L of sin t. Now what is L of e power t? 1 by s minus 1. What is L of sin t? Standard function 1 by s square plus 1. So this completes the solution for this problem. Now next one, find the Laplace of e power minus t u of t minus 2. So here also you have the product. So first write the Heaviside shift theorem. Laplace of f of t minus a u of t minus a e power minus a s f of s. So Laplace of e power minus t u of t minus 2. See, you see the theorem. You have the variable as t minus a, u of t minus a, f of t minus a. So here also it should be t minus 2. So to get t minus 2, we are adding and subtracting 2. So Laplace of e power minus of t minus 2 plus 2 u of t minus 2. So now you split the exponential term, e power minus of t minus 2 into e power minus 2 u of t minus 2. E power minus 2 is a constant, so take it out. Laplace of, so e power minus 2 into Laplace of the product, e power minus of t minus 2 u of t minus 2. So what is it by Heaviside shift theorem? A is 2, so e power minus 2s into L of f of t. What is f of t? E power minus t. This is a step function, u is a step function. So what is f of t? You just delete a. What is f of t? E power minus t. So e power minus 2, e power minus 2s into Laplace of e power minus t. What is Laplace of e power minus t? Standard function 1 by s plus 1. What is Laplace of e power minus t? 1 by s plus 1. So that's what we have here. So e power minus 2s by e square into s plus 1. Next we have a problem of same type, sin t plus cos t into u of t minus 2. So here also you have to find the Laplace of the product. First thing, write the Heaviside shift theorem. So Laplace of f of t minus a u of t minus a e power minus as into f of s. So here if you see the, if you observe the expression, you have sin t plus cos t, but the variable should be same. In both the places you should have t minus a. So to get t minus pi by 2, we are adding and subtracting pi by 2 to t. So Laplace of sin of t of pi by 2 plus pi by 2 plus cos of t minus pi by 2 plus pi by 2 into u of t minus pi by 2. See, you can use Heaviside shift theorem only when you have functions in t minus a. So to make use of Heaviside shift theorem, you add and subtract pi by 2 to t. So sin of t minus pi by 2 plus pi by 2 plus cos of t minus pi by 2 plus pi by 2 into u of t minus pi by 2. So split into two terms. So Laplace of sin of 90 plus t minus pi by 2 into u of t minus pi by 2 plus Laplace of cos of 90 plus t minus pi by 2 into u of t minus pi by 2. So what is a here? What is a here? Pi by 2. So e power minus pi by 2, yes. Compare with the Heaviside shift theorem. What is a? Pi by 2. So e power minus pi by 2, yes. Now what is f of t? Sin, what is sine of 90 plus theta? Cos theta. What is cos of 90 plus theta? Minus sin theta. So that's what we have here. E power minus pi by 2 is Laplace of cos t. Why we say Laplace of cos t? Because sine of 90 plus theta is 90 plus t is cos t. And here plus e power minus pi by 2 is what is cos of 90 plus t? Minus sin t. So that's what you have here. So I repeat, a is pi by 2. What is f of s? L of f of t. So what is f of t here? Laplace of sine of 90 plus t, that is cos t. And what is f of t here? Laplace of cos of 90 plus t, that is minus sin t. So what is Laplace of cos t? Cos t and sin t are standard functions. So Laplace of cos t is s by s square plus 1. Laplace of sin t is a by s square plus, that is 1 by s square plus 1. So that's what you have here, e power minus pi s by 2 into s by s square plus 1 minus 1 by s square plus 1. So this completes the solution. So far we have discussed problems using Heaviside shift theorem. Now I will explain problems using the theorems, theorem 1 and theorem 2. So this is one type, type 1. You just have to find the Laplace using Heaviside shift theorem. Now type 2, express the following in terms of step function and hence find the Laplace transform. So type 2, you will have the question f of t defined in two subintervals or three subintervals. So here I have taken one problem for two subintervals and one problem for three subintervals. So if you have a problem defined in two subintervals, make use of theorem 1. What is theorem 1? F of t equals f1 plus f2 minus f1 u of t minus a. So what is f1? T square. What is f2? 4t. And what is a? 2. So f of t equals t square plus 4t minus t square into u of t minus 2. Then take Laplace on both sides. So Laplace of f of t. So here we have this is for the first part. We have expressed f of t in terms of step function. What is the question? Express the following in terms of unit step function. So first thing, we have expressed f of t in terms of unit step function u of t minus 2. The second part is to find the Laplace. So we have taken Laplace on both sides. So Laplace of f of t equals Laplace of t square plus Laplace of 4t minus t square into u of t minus 2. Now what is Laplace of t square? 2 factorial by s cube. Laplace of t square is a standard function, so 2 factorial by s cube. What is Laplace of t square? 2 factorial by s cube. That's what we have used here. And here you have the product. Whenever you have the product, you have to make use of Heaviside shift theorem. So what is Heaviside shift theorem? L of f of t minus a u of t minus a equals e power minus as into L of f of t. So here what is a variable? T minus 2. So here also you should have t minus 2. What is Heaviside shift theorem? L of f of t minus a u of t minus a e power minus as into f of s. You should have t minus a in both. So here also you have the product. You have to find Laplace of the product. Here what is a step function? U of t minus 2. So 4t minus t square should also be expressed in terms of t minus 2. So for that we are taking minus out. So minus of t square minus 4t. So minus of t minus 2 whole square, that is t square minus 4t plus 4 minus 4. So we are expressing it as t minus 2 whole square minus 4. First minus is taken out, so minus of t square minus 4t. In the next step, we are expressing it as function in t minus 2. So t square minus 4t means t minus 2 whole square, and you are adding and subtracting 4. So that's what you have here. Then 2 by s cube minus, you take it out, Laplace of t minus 2 whole square u of t minus 2 plus minus of minus plus 4 times Laplace of u of t minus 2. So what is this by Heaviside shift theorem? What is a? 2. So e power minus 2, yes. And what is f of t? T square. If f of t minus 2 is t minus 2 whole square, what is f of t? T square. So e power minus 2s into Laplace of t square. And what is Laplace of step function by property 1? E power minus as by s. So that is e power minus 2s by s. So this completes the solution for this problem. So wherever you have product, you have to make use of property 2, that is this one. You have to by heart. By looking at the function, you should identify, by looking at the function, you should be able to write the right side. So, and the thing is, you should have both the variable in same variable. You should have the same variable in both u and f. So see u, look at the function u. whatever you have in u, you should get in f also. That's what we have done here. It is u of t minus 2. So I have simplified 4t minus t square to a function in t minus 2. So you just have to simplify, take minus out, minus of t square minus 4t. So how you can write it as t minus 2? I can write this as t minus 2 t square minus 4t plus 4 minus 4. The next step, minus of t minus 2 whole square minus 4. Then we are splitting into two Laplace transforms. Here we are using Heaviside shift theorem. What is now the variable is same. The variable in f and t are same. So what is that variable? T minus 2. And what is a2? So e power minus 2s into Laplace of t square. And this is Laplace of step function. What is Laplace of step function? By property 1. E power minus as by s. So here a is 2. So e power minus 2s by s. Now we have a problem for 3 subintervals. If f of t equals 1, you see here we have a problem defined in 3 subintervals. F of t equals 1, 0 for t lying between 0 and 1, t for t lying between 1 and 2, t square for t greater than 2. So if a function is defined in 3 subintervals, then you should make use of this theorem 2. So what is theorem 2? f1 plus f2 minus f1 into u of t minus a plus f3 minus f2 into u of t minus b. So if a function is defined in 3 subintervals, you should make use of theorem 2. You should by heart the statements of theorem 1 and 2. So what is the statement of theorem 2? Yeah, f of t equals f1 plus f2 minus f1 u of t minus a plus f3 minus f2 into u of t minus b. Now what is a here? Ignore 0. What is a? 1. B is 2. Leave 0. What is a1? The constant a is 1, constant b is 2. f1 1, f2 t, f3 t square. So 1 plus t minus 1 u of t minus 1 plus t square minus t u of t minus 2. So 1 plus t minus 1 u of t minus 1 plus t square minus t u of t minus 2. Now after now in the next step you can take Laplace. So Laplace of 1, you know, 1 by s, and here you have the product, so you can make use of Heaviside shift theorem. And here we are splitting into 2, t square u of t minus 2 minus t into u of t minus 2. So I told you whenever you have the product, you should have the same variable in u1 f. So we are adding and subtracting 2 to this t, and here also we are adding and subtracting 2. So you have t minus 2 plus 2 whole square u of t minus 2, and here t minus 2 plus 2 u of t minus 2. Now in the next step, 1 plus t minus 1 u of t minus 1. So this is of the form a plus b whole square. So t minus 2 whole square plus 4 times t minus 2 plus 4 into u of t minus 2. And here we are splitting into two terms, minus of t minus 2 u of t minus 2 minus 2 into u of t minus 2. I repeat, if you have a function defined in 3 subintervals, write the formula first. This is the formula by theorem 2. Leave 0. A is 1, B is 2, f1 1, f2 t, f3 t square. Substitute that here. Then you see here 1 plus t minus 1 u of t minus 1. Here we have the same variable in both, but here we don't have. So the variable should be t minus 2. So for that, to get same variable, we are adding and subtracting 2 to t. So in both these terms, so t minus 2 plus 2 whole square, and here t minus 2 plus 2. So next step, this is a plus b whole square. So a square plus 2ab plus b square, and here this is split into two terms. So f of t equals 1 plus t minus 1 u of t minus 1 plus t minus 2 whole square u of t minus 2 plus 4 times t minus 2 u of t minus 2 plus 4 times u of t minus 2 minus of t minus 2 u of t minus 2 minus 2 times u of t minus 2. So if you simplify, 1 plus t minus 1 u of t minus 1 plus t minus 2 whole square u of t minus 2. Then 4 minus 1 is 3. So 3 times u of t minus 2, 3 u of t minus 2 u of t minus 2. 4 minus 1 is 3. So 3 times t minus 2 u of t minus 2. And here you have plus, and here you have plus 4 minus 2. So plus 2 times u of t minus 2. See, these two terms, they are same, and t minus 2 whole square u of t minus 2 is there. Only the last two terms, the last four terms you have to simplify. So 4 times minus 1 times, so it is 3 times t minus 2 u of t minus 2. And here you have 4 times u of t minus 2 minus 2 times u of t minus 2, that is plus 2 times u of t minus 2. Now you take Laplace on both sides. What is Laplace of 1? 1 by s. And what is it? Here you have the product. So what is a here? 1. So e power minus 1 into s into L of f of t. What is f of t? T. And here e, what is a here? E minus 2. A is 2. So e power minus 2 is Laplace of t square. And here 3 times e power minus 2 is Laplace of t. And 2 times, what is Laplace of step function? E power minus as by s. So that is e power minus 2s by s. I repeat, Laplace of 1, 1 by s. And here you compare with the heavy side shift theorem. This is a heavy side shift theorem. A is 1, so e power minus 1 into s, Laplace of t plus t minus 2 whole square u of t minus 2, a is 2, so plus e power minus 2s, Laplace of t square, plus 3 times e power minus 2s, Laplace of t, plus 2 times e power minus 2s by s. So this completes a solution for this problem. So we have simplified. Then you take LCM and simplify. So we have grouped the constant e power minus s term, e power minus 2s terms. So you get this as a solution. So with this I complete the step function. You listen to the video, you practice the questions given, shared in the notes, and the problems given in the textbook. Still, if you have doubts, you can get it clarified. You can call me or send message in WhatsApp and get it clarified.